Hi, and welcome to this video on creating your own lava lamp at home. This is a really fun experiment, which you can do using things you probably already have lying around the house. Just be sure to ask an adult to help you pour things out, and also when using Alka-Seltzer tablets. So to make your own lava lamp, you'll need 4 key ingredients. These are vegetable oil, olive oil or baby oil will be fine, Alka-Seltzer tablets, the kind that make water go fizzy, and food coloring, to make it the color of your choice, with some tap water. Be sure to get a container you can put it all into. I used an old water bottle, but anything clear will do just fine. The first thing you will need to do then is fill your container about a quarter full with tap water. Then top it up with your vegetable oil so the container is almost full. To this you can also add your food coloring. You're going to notice that the two liquids will not stay mixed. The water will sink to the bottom with the food coloring, while the oil is going to float to the top. You can tell because a thin line, called a layer, will be near the bottom of the bottle. This is formed because the liquids have different densities. I'll talk more about that at the end. So once the two liquids have separated, you can make it into a lava lamp. Take an Alka-Seltzer tablet and break it in half. Drop one half into the container. The tablet is going to fizz. This means it's making bubbles, which are little pockets of gas, and they'll float towards the top. The bubbles are made of a gas called carbon dioxide. So this is where the fun begins. Small blobs of water are going to be carried up to the top of the container by the bubbles from the Alka-Seltzer tablets. These are coloured so you can tell them apart from the oil. When they reach the top, the bubbles break and the water falls back down to the bottom. But why does the water sink like this? And why does the oil float? So the answer lies in density, the thing I mentioned earlier. And density is a way of understanding the weight of different liquids. So if you imagine two bottles, one full of water, one full of oil, the bottle of oil is going to be lighter, even though it has the same amount of liquid in it and it's the same size and everything. This is because the oil is less dense than water. And because of this, when you combine them in the same bottle, water wants to sink to the bottom while the oil wants to float to the top. It's the same reason that you don't sink if you go swimming. You're less dense than the water that you're swimming in, so you float to the top. And that is the reason why these two liquids didn't mix when you first added them together. However, when you add the Alka-Seltzer, it produces carbon dioxide gas, and carbon dioxide gas has a much lower density than either oil or water. Because of this, what happens is the little bubbles, they crowd around the blobs of water and they carry it up to the top. Because they're much less dense than the oil or water, they float to the top and they take the water with them. But as soon as they hit the top of your container, of course, the bubbles of gas are released into the air. So the water blobs, now unsupported, just sink back down, ready to be picked up by another lot of bubbles. Going back to our experiment, if your lava lamp is starting to slow down, you can add the other half of the Alka-Seltzer tablet. In fact, you can add tablets for as long as you want, and your lamp will keep going. Once you've tried this, maybe try adding different colors or experimenting with different amounts of oil or water to see how the lamp changes. Thank you for watching my video and have fun making your lava lamp at home.
Archimedes was born circa 287 before Christ in the seaport city of Syracuse, Sicily, and lived for 75 years. According to the popular account given by Plutarch, Archimedes was contemplating a mathematical diagram when the city was captured. A Roman soldier commanded him to come and meet General Marcellus, but he declined, saying that he had to finish working on the problem. The soldier was enraged by this and killed Archimedes with his sword. The last words attributed to Archimedes are "Do not disturb my circles", a reference to the circles in the mathematical drawing that he was supposedly studying when disturbed by the Roman soldier. But there is no reliable evidence that Archimedes uttered these words. A biography of Archimedes was written by his friend Heraclides, but this work has been lost, leaving the details of his life obscure. It is unknown, for instance, whether he ever married or had children. The most widely known anecdote about Archimedes tells us how he invented a method for determining the volume of an object with an irregular shape. According to Vitruvius, a votive crown for a temple had been made for King Hiero II of Syracuse, who had supplied the pure gold to be used, and Archimedes was asked to determine whether some silver had been substituted by the dishonest goldsmith. Archimedes had to solve the problem without damaging the crown, so he couldn't melt it down into a regular shaped body in order to calculate its density. While taking a bath, he noticed that the level of water in the tub rose as he got in, and realized that this effect could be used to determine the volume of the crown. For practical purposes, water is incompressible, so the submerged crown would displace an amount of water equal to its own volume. By dividing the mass of the crown by the volume of water displaced, the density of the crown could be obtained. This density would be lower than that of gold if cheaper and less dense metals had been added. Archimedes then took to the streets naked, so excited by his discovery that he had forgotten to dress, crying, "Eureka!" The test was conducted successfully, proving that silver had been indeed mixed in.